everybody. I'm very excited to be back in my home state of Florida. I was born and raised down in Homestead. I went to school in Orlando. Is a Homestead guy?
Westchester, but right around there.
Close enough, yeah. Well, you got killed by a hurricane. That's cool. We're all the same. I live in New York City now, where I am a web developer. I started a new job a few weeks ago. I now work for Microsoft, where I get to work on my open source project called Glimpse. That's a sticker for Glimpse. That's not the actual open source project. Has anybody, can I get a show of hands, has anybody in the room seen or heard of Glimpse or used it? Okay, a smattering. Was anybody in my session at Code on the Beach last year? Hey, thank you for returning. I appreciate that. So this session is kind of going to be the spiritual successor to last year's session. If you weren't here last year, don't worry, they're not really related at all. But there is a video of that session online, and I will provide you a link to that at the end of this session. The two go together really well. If there's one thing that you do note, if nothing else during this session, it should be my Twitter handle, NickMD23. It's a horrible handle, but it's consistent. That's what I use everywhere. Twitter, GitHub, Gmail, Skype, you pick a service, that's me. Because if you miss something or have a question or want some resource or whatever, I'm always happy to answer questions on Twitter. So let's go ahead and jump into performance. Before we get too far into the muck of performance, I want to stop and take a step back and think about Colonel John Boyd. My favorite colonel, any guesses? Colonel Sanders, clearly. John Boyd was a pretty cool colonel, though. Back in, right after World War II, I'm sorry, after the Korean War, he's not that old. He was in Nevada teaching at the prestigious air fighter school, and he came up with the idea of the OODA loop. The OODA loop is a decision-making framework that was largely credited to some of America's military dominance in the ensuing years afterwards. Basically, it's very simple, breaks down into 4 steps. The first step is observe. You take in as much data as possible as you can from the environment around you. Then you orient, you shape that data into a mental model that's easy to understand. Then you decide, you figure out what you're going to do with what you've learned. And then lastly, you act, you implement that change. And it's named OODA loop for a reason, because when you get to act, you loop back around to observe. Technically, you can loop back around to observe at any time. You might get to the decision point and realize you don't have enough data and go back to observation. Now, the OODA loop has been extended outside of military. It's used in all kinds of industries like litigation and business. And this is the lens through which we are going to look at performance today. I mentioned last year's session. The only reason I did that is because last year we only focused on decision making and actions. This year we're only going to focus on observing and orienting. So we're going to make a website faster. That's what we did last year. But this year we're going to look at why I made the changes that I did. So that's the OODA loop. That's the lens we're going to use. But before we can even get into observation, we have to figure out a way to capture what we've observed. And to do that in web performance, we use lots of various metrics. Now there's tons of metrics out there, and it's a little squirrely to try to navigate that whole space. So we have a breakdown of metrics into 4 different categories: quantitative, rule-based, milestone, and perceived. Now, if you know any web performance metrics at all, it's probably quantitative metrics. These are simple number-based metrics, like the number of HTTP requests to render a page, the number of domains that page connects to, the number of redirects or weights, right? Like the total weight of the page, the weight of the images on the page, the weight of the JavaScript. So these are really simple numbers, and the beauty of them is that they're easy to compare. The thing that sucks about quantitative metrics is they don't actually tell you anything about performance. If I tell you that my page has 3 JavaScript files on it, does that make my page fast or slow? You don't know, because they're not about performance. But they're good for comparison. So if I told you that I implemented the page the first time with 3 JavaScript files and the second time with 1 JavaScript file, your gut might say that the second time I implemented it, the performance got better because there's less JavaScript files there. So those are quantitative metrics. Next, we have rule-based metrics. So rule-based metrics basically extend quantitative metrics, do some analysis against industry best practices, and then give you a score or a grade to let you know how you're doing. We have a lot of people standing in the back, so if you guys wouldn't mind defragging towards the middle a little bit, freeing up some space on the aisles, and then all of you guys just continue to stay standing, because that would make me look stupid. No, please sit down and enjoy to the best of your ability. So let me repeat real quick there since I just got off track. So rule-based metrics are metrics that look at your quantitative metrics or at your site, compare it to industry best practices, and tell you whether or not you're doing well. And you'll get a grade or a score. So maybe you've seen Google Pagespeed in the past, and that might say you got an 88%. Or you used Yahoo's YSlow that says you got a B. So that's one nice number. That's great. But if I have a B or an 88, once again, I don't know if my site is fast. I just know that I'm following the current best practices, which might not be the practices that are right for my site. And if I go from B to A, I could actually still technically get slower. And so rules-based metrics are great for making sure that you're getting through all the low-hanging fruit and figuring out what you should do as first steps for performance, but they don't actually measure performance. The next ones that we'll get to are milestone metrics. Now, milestone metrics, this is where we actually start to talk about performance, because milestone metrics are all about measuring time. And there's lots of them, and you've maybe heard of them before, but let's go ahead and walk through a few different milestone metrics. So here's a browser that I've created. I call it Internet Chrome Fox. If you have a better name, then just let me know. So essentially what's happened at this point in time is the user has fired up the browser. They've typed in a URL. In this case, it's https://stratostore.com/login. But they have not hit go. They haven't clicked on the arrow or pressed the enter key. All right? This is the moment when a milestone is about to start, because the second they hit enter or do whatever gesture it is in Internet Chrome Fox that makes the navigation begin to happen, a timer starts. And that timer is measuring how long it takes for the browser to process different parts of the page. The very first milestone we'll reach in that processing is the time to first byte. This is how much time passed between the moment the user hit enter to when the server sent back the first byte, and that byte went through the internet and landed at the browser. Notice there's still nothing displayed in the browser. That's because the first byte is probably an H character, right, telling you that you're running on HTTP 1.1 or something like that. There's nothing that can actually be displayed. So a lot of developers look at time to first byte to figure out, is my backend fast or slow? Which is fair enough. But the problem with time to first byte is it's a bit of a blocky and obtuse metric. So I'm going to press F12 here on my machine and open up Internet Chrome Fox's developer tools. Thank you. I appreciate that. Pity laugh. OK. My mom is going to see this, guys. Make me look good. So you might recognize these tools from the other crappy browsers that you guys use in your day-to-day, but all the browsers have a network panel, and that network panel will break down the different requests. So you see here, there was a request to log in, and here's all the time that happened between enter, or here's all the things that happened between enter and time to first byte. Time to first byte is actually this moment right here where we went blue. That's time to first byte. But notice there's all of these other things that happen. So when the user presses enter, the first thing that any browser will do is they will look at the host name, in this case, stratostore.com, and do a DNS query to figure out the IP address that goes for that host name, represented here in blue. Once we have an IP address, now we can go ahead and create a TCP socket connection. And that takes some time. There's a multi-packet handshake that has to happen. And so we do that connection. Once the connection is established, it just so happens that we're running through an HTTPS site right now. And so we have to do a little bit more negotiation for TLS, transport layer security. So because this is secure, we do all of this pink stuff. Now that we know where we're connecting to, we've connected to it, and we've encrypted the connection, we can actually fire off the HTTP request. So this is kind of the upload, the browser sending, this is the file that I want, and here's all the parameters that I want to go with it. And then finally, we hit time to first byte. So I mentioned developers will look at time to first byte and use this as an indicator of their server backend time. Sure, but because it's so blocky, maybe there was internet problems and TCP connection took a long time, or maybe the DNS isn't being propagated properly, and so you're doing lots of DNS query time. So if you want to use this metric, you really need to break down into all of these various pieces. But let's continue down the milestone processing pipeline. After time to first byte, we might hit time to first paint. This is the moment that the browser has painted some pixels to the screen, and we're no longer just looking at a blank page. Now, I very specifically said some pixels. not necessarily good pixels. There's just something showing up. And so in this case, part of the HTML is starting to be downloaded, and we see something getting dumped out. That's probably going to change because we're continuing to render the page and paint to it as we go. The reason why this metric is very popular is because both IE and Chrome expose proprietary methods in JavaScript for getting access to this time. So a lot of people like to use this as an indicator of how quickly pixels are getting painted to the screen. Next, we come to a metric that you might recognize, which is DOM content loaded. DOM content loaded and onload are very recognizable because the real browser developer tools, they always have like a blue and a red vertical line in their networking timelines that show off these milestone metrics. So what time to DOM content loaded is the moment when the browser has downloaded all of the HTML, parsed it, downloaded any blocking JavaScript or CSS that might be required as well, parsed that, and built up the document object model that represents that page. And it fires off an event saying, hey, any JavaScript that cares, the object model is ready, you can begin interacting. But this is not the complete page. This is not what the finished product looks like. We're still missing a lot of images and things like that. DOM content loaded does not mean I've finished loading everything. It just means that it's interactive now. Onload means I've finished downloading everything. I got the HTML and all the images and all the CSS and all the JavaScript that it told me to go and get. Boom, now we have onload. Now, I don't know. I just took about 5 minutes to walk you through 4 different milestone metrics. And that is kind of the problem with milestone metrics, is they're very technical. You need to understand the inner workings of the browser and the DOM and the networking stack and all the things that are happening so you can quantify these numbers. Imagine sitting down with your non-technical manager and telling him, oh, well, our performance is fine because DOM content loaded is X, but onload is Y, and so that's a bit of a problem because, and you have to explain this whole thing that I explained to you. That's the problem with milestone metrics. They're good because they are getting back to the heart of performance, but they don't tie back into what our stakeholders care about. So what companies are beginning to do is create custom milestone metrics, time to X. This became very popular because I think Twitter was the first ones that really publicized they were doing this. Twitter uses a metric called time to first tweet. That's how much time does it take from the moment you hit enter or click on a link or whatever, begin that navigation gesture, to the first tweet of your timeline appears. Because that's the content that Twitter cares about. And YouTube has something similar. It's time to video playback. How long until you're seeing the first frame of that video playing in your browser? So on Stratus Store, this is a login page. So we might have time to password field focus. That's how much time it took to render the whole page, pop my username out of a cookie, and then focus so the user could just type in the password and go. We can maybe make a custom metric around that. So that's my lap around milestone metrics. But there's one more type of metric, which is kind of the holy grail. This is the metric that everybody wants right now, and that's perceived metrics. The challenge with milestone metrics is partly because they're so technical. So my buddy Cecil here in the first row, he's a brown noser. He's right up here. But he's a really cool guy, right? So I'm kind of old school. I got a lot of gray going on. And so I might build a page that has an onload time of 3 seconds and that shows some content. But because I'm old school, I just used MVC and I shipped all my content down to the browser and bang, I was done. But Cecil, who's cool, he builds a web page that also has an onload time of 3 seconds. But he's using like reactive Angular JS. I made up a framework. That's what he's using. I stumbled over my own words and invented something. That was awesome. That's what he's using. So at onload at 3 seconds, the users don't see anything because he's then firing off all these AJAX requests and going to web API to get some JSON data and render a template. So technically, from a milestone perspective, Cecil and I have pages that are equally as performant. But any user who looks at that page would perceive my old-fashioned, boring page to be faster because they're getting to the content that they want faster. I am a Pluralsight author, and has anybody used Pluralsight here? Their page drives me absolutely nuts because this is what they do. Every time you click on something, it's like, Pluralsight, nothing, spinner, stuff. It's like, oh, stop! So there have been many different companies who have tried to make perceived metrics. Google, Microsoft, there's been user community initiatives. There's things called user ready time, above the fold render time, page phase time. You've never heard of any of them because all of them were so complicated to calculate and they all just kind of fell away. There is one that's left remaining, and that's called speed index. And so it's a really cool metric. It is kind of the holy grail right now. If you're doing any measurement of your site, this is probably the one metric you should watch if you're only going to watch one. And so let me explain to you how it works. So we just walked through all these milestones, and we were loading up stratusstore.com. Let's imagine that we took a video camera and we recorded that page being loaded, and then we looked at the film strip. This is an old school analog camera, not digital. And so you can see here at the very beginning, 1 second into the load, we would say that this frame was 0% visually complete, right? We know what it looks like all the way at the end when it's done, and this looks nothing like that. And so 1.5 seconds in, we're also at 0. At 2 seconds in, maybe this is 14%. We're starting to get some of the pixels painted to the screen. 2.5 seconds in, we're at 57%. At 3 seconds in, we're 95%. And then, off the screen, we hit 100%. So speed index actually does this. And then it takes all of those percentages, the 0, the 14, the 57, and it plots it on a graph. So this graph here is showing you 2 different requests. So request 1 in yellow, you can see maybe a half a second has passed and it shoots up to being about 70% visually complete and then kind of meanders on for the rest of the time until the end here where it goes, I don't know, let's say it goes from 90 to 100. Whereas request number 2, you'll see shoots up pretty quickly to 25%, but then there's no changes to the screen until later on where it shoots up. And I want to point out here that these 2 requests at the end, the last, let's just call that 1 second, are tracking the exact same. So they're finishing loading. This is me and Cecil's example again. They're finishing loading at the same time, but what the user is seeing is different. So how can we turn a graph that looks like this into a metric that's easy for us to discuss? Math. So this is an integral. Trust me, I'm not a mathematician, so don't be scared. Basically, this is the formula, this is a slightly modified version of the formula for finding the area above a curve. And what we're doing here is we are going to walk that line in 1/10 of a second increments and use that to calculate the area above that curve. So if we take the first request, the area is a shape that looks like this. If we run it through our integral formula, we'll get a number that is 1,343 because we're dealing with time here, and this is all measured in milliseconds. That's 1,343 milliseconds. That is the speed index for request number 1. So let's go ahead and look at request number 2. And you can see that that area, I don't even have to say anything. Request number 1, request number 2. This request is clearly a bigger, heavier shape, and thus your users will perceive request number 2 to be bigger, heavier, slower. And likewise, we get a speed index that's higher, 9177. So we want a low speed index. All right, so that was my quick lap around metrics. Sorry if I scared you with any math. Now that we're kind of all level set on the things that we're talking about and how we measure, let's figure out how to gather those measurements. All right, so here's the problem. If you guys are anything like me, you code up a new website or you add a feature to your corporate intranet or whatever you do, and you hop on your machine and you bang on it a couple of times. Maybe you're like a 10x developer, so you open 2 browsers and bang on it a couple of times. And you walk away and you say, hey, guess what, boss? It works on my machine. Nice and fast, yeah. Here's the problem with that scenario. The problem with that scenario is my machine. My machine is the same machine every single day. It runs the same 1, 2 browsers. It's on the same corporate Wi-Fi or internet connection. It's running the same operating system. It's got the same hardware. It's the same every single day. My users, on the other hand, they have all different connections. Sometimes they're on flaky code on the beach Wi-Fi. Is Paul in here? All right. Ixnay on that, yeah. Sometimes they're using Macs. Sometimes they're using Windows. Sometimes they're using little devices that fit in their pockets, right? Sometimes they're riding on a camel in the middle of Egypt using Firefox OS. I think that's where Firefox OS is used. And so what we would honestly need to do realistic performance testing is test every single one of those configurations, every single one of those environments. And if we just consider 4 variables, the browser, the platform, the connection, and the geolocation, that will create a matrix that's way too long for any of us to do any work. So that's a problem. So what are we going to do? Well, I have a crazy idea. My idea is to, instead of me doing performance testing, I'll still do some performance testing, but unleash my users to be the performance testers, because they have 100% coverage of every environment that's ever used, right? So this would be ideal. Okay, great. Well, how do we do that? Well, that's where real user metrics come in. And lucky for us, at the W3C, there's a group of people called the Web Performance Working Group who works on solving basically just this problem. So they write a bunch of specifications that say browsers need to expose lots of the different metrics that we just learned about so that web developers like us in this room can figure out how pages are really loading, really for their end user, for the guy on the camel in Egypt. What was his experience like? So you can then capture that and observe properly. So there's a bunch of different specs that the Web Performance Working Group makes. Today we're going to look at the navigation timing, resource timing, and user timing APIs. Now, the navigation timing API specifies a timeline that looks like this. Now, if you were paying attention to the F12 tools and Internet Chrome Fox, you will recognize the section from here to here. DNS, TCP, request, response. Exact same timeline. The navigation timing specification adds a little bit of stuff over on your left with redirects and looking in any irrelevant caches, and a little bit of stuff on your right, which is JavaScript basically stuff processing and loading and things like that. So this timeline is created, and then all different points along the timeline are given names, right? So we see things like domain lookup start, domain lookup end, response start, response end, et cetera, et cetera. All of these annotations on the timeline are stuffed into one object, and that object is given to you to take a look at. So let me go ahead and switch over to my browser. This is the app that we made faster last year. It is hosted publicly, so you can take a look at the differences. If you go to mascots.azurewebsites.net, you will see the old version, the before version. This is the slow version. If you head over to mascots-staging.azurewebsites.net, you'll see the after version. This is the version that we optimized a little bit. And so I'm a huge baseball fan. I'm a Miami Marlins fan. The Miami Marlins have the most amount of losses for all but one team this year. But I'm actually excited to be here in Jacksonville because you guys might not know this, but in the Southern League, you guys have a local team here called the Jacksonville Suns, and they happen to be the AAA affiliate for the Marlins. So the guys who play here, the next step up for them is to go down to Miami. But because I know nobody else in here cares about baseball but me, I decided to compromise, and instead of building a site about baseball players and baseball stats, we would build a site about baseball mascots, specifically the mascots of minor league baseball. And so every year, this is true, I'm not making this up, they have a contest called the Mascot Mania contest. It's like the Olympics of mascottery. And so that's another framework. And so they have different events like pie throwing and t-shirt gun sharpshooting. And so I have this page here that shows off all the people who were, this is true, this is not a joke, that was very serious. All the mascots who made it to the finals of that this year. My favorite mascot is here. He cheers for the team in San Antonio. His name is Balapino. He is a half jalapeno, half baseball bat, and as a fat baseball fan, does not get any better than that. So anyway, what we're going to do is we're going to take a look at this website, and do you remember we were talking about the navigation timing API? So in my browser, I'm going to press F12. I'm going to open up these so-so developer tools, and I'm going to go ahead and type in window.performance. Now, .performance is the property that web working group lives in. So everything that's inside of this thing is gold. I recommend you just go start fiddling around with it in your dev tools. But I'm going to say .timing, and I get back this object, which is the names of all of those. I'm going to go back to console, which is the names of all of those properties that we mentioned on the timeline and timestamps that show when they happened. And so I can just do simple subtraction between any of the two moments in time and find out how many milliseconds it took between the beginning and the end. So if I want to know how long DNS took, I can look at domain lookup start and domain lookup end, subtract one from the other, boom, Bob's your uncle, I got that. Now I know what you're thinking, Nick. Showing me a dump of an object in the console is really sexy. What's sad is 3 of you were then thinking of it. So instead, I'll show you something a little bit better. There's a bookmarklet that uses this API to paint something a little bit more visually appealing to the screen. So I'm going to click on that bookmarklet, and boom, now you can see all of that stuff broken up. They broke the timeline up into 3 phases, which is red, which is the kind of the networky type stuff, yellow, which is kind of the back-endy type stuff, and then blue, which is everything that's happening on the client machine. And so you can see from 75 to 117, so let's call that like 35 milliseconds it took for my response to happen. Of course, I have a lot of stuff cached. So that's really cool. Now, one thing that you might notice about all of that data is it was only information about the HTML. What about all the JavaScript and the CSS and the images? Well, the navigation timing API has a problem with that. I'll also point out before we move on, the support for navigation timing is really good, IE9 and better. Because all of those assets were missing, the working group said, all right, that's fine. We're going to create another spec called the resource timing specification. It basically works the exact same way, except you'll notice that the timeline is a little bit smaller. There's no processing stuff. There's a little bit less. There's no processing stuff at the end here. And likewise, it is annotated with a bunch of different points in time that we can get access to. So let's go back to our browser. I have links to all of them. I don't know the name of it, but I have links to all of them at the end. So I'm going to come back into my DevTools. I'll do window.performance. But instead of doing .timing this time, I'm going to say get entries by type. Now the type of entry that I'm looking for here is a resource. So I type in that name. And I get back an array of objects, where every element in the array is another one of the resources that was required by this page. And if I go ahead and I open up any one of them, so this one, you can see that I'm downloading the Carolina PNG. That's the league icon for the Carolina League. And you can see, once again, my domain lookup, my domain end. And this specification, because it's newer, uses an even better timer that's built into the browsers. And you get sub-millisecond accuracy. So you get really, really fine-grained with this. And once again, you can just do some subtraction and figure out how long things are taking. Now, you're like, wow. He showed me data in the browser twice. Now that's really hot. No, you're not thinking that. So another bookmarklet, this one that taps into the resource timing API and generates this heat map that shows me which resources on my page are slow and which ones are doing well. Let's go ahead and try to hard refresh so I download everything again. And there you go. Now you can see when I did a hard reload what happened with that time. So that's pretty slick just by using that one little API. All right, so, and you can see support is decent, not as good as navigation timing because it's slightly newer. Well, that's great. We got all of the milestones that I covered out of the way with 1 or 2 very simple JavaScript calls. But here's the problem. What about Twitter? What about YouTube? What about time to password field focus? The working group comes through again and created a specification called user timing, which also is fairly well supported, except for Safari, because Apple just doesn't care anymore. They don't. Here's the sample of code. Let me actually just show you the real code. We're going to go open up Visual Studio here. Now, I happen to have built this website in ASP.NET MVC. If you're not a .NET guy, that's fine. It doesn't really matter. This is just JavaScript. This would work anywhere. So what I'm showing you here is, let me show you the page that we're working on here. If I come and click on one of these leagues, I will find, let's go look at Finley. So Finley has taken rooting for his team to the digital age, and he roots via Twitter. So because of that, I suck in his Twitter feed and show it on the page, and you can come here and see these really important tweets. So the code that does that is here. Starting on line 7, you'll see that I make a call out to platform.twitter.com/widgets, and that's how I get Twitter's JavaScript file. And then as soon as that's loaded, I open up on line 8 into my own JavaScript. And line 9, I call performance.mark. So this window.performance.mark. This is where user timing comes in. It has two methods. It has one called mark and one called measure. And what mark allows me to do is to take that timeline and put a custom milestone on it. It's like at that moment when that line of code runs, I want you to call it load Twitter script end. I called it that because we just finished loading the Twitter script. And so boom, that's the first moment that I have to mark when that happened. And then the Twitter API gives me some functionality that this Twitter object, and it has a callback for when it is ready to do its work. And so I'm holding on to that. And so I do another mark, right? Drop another breadcrumb. And I say, OK, now Twitter is ready. So the first one, it was loaded, and now it's ready. And then Twitter has another event that I'm going to bind to called rendered when it's finished doing its rendering. And I'll do another mark this time, and I'm going to say that Twitter was rendered. So I have 3 different marks. It was loaded, it's ready, it's rendered. That's the first API call that we make of that spec. The second one is .measure. And what that allows me to do is I say, I want to do the math automatically between when Twitter was ready and Twitter was rendered. And let's call that the Twitter render time. All right, so let's go ahead and look at how we're going to use this in the browser. I'm going to press F12. Once again, window.performance.get entries by type. And this time I want all of my marks. So I will ask for mark. I get my array of my 3 marks. You can see them there. Twitter ready, load Twitter script end, and Twitter rendered. And we get a start time, which is when that thing happened, in sub-millisecond accuracy. And obviously the durations are all zeros, because they're just moments in time. They're not measurements of time. It's not a time span. If I want to get the time span, instead of asking for the mark, I ask for the measure. And I have one of those. And you can see the duration between when Twitter was ready to when Twitter was rendered is 503 points blah milliseconds. So it's like half a second after I already downloaded all the JavaScript and parsed it just to get the thing to show up on the page. OK. Am I going till 2 o'clock today, guys? All right, 4 o'clock it is. Perfect. Once again, you guys get the pattern here, right? I show you something really sexy, and then I show you something lame. And so this bookmarklet kind of pulls all of these APIs that we've talked about together, and it prints out this kind of quasi-waterfall. But what you'll notice is in this waterfall, we have these lines that show up here. These are the lines of, oh no, these lines right here, these gray lines that I'm hovering over now to make turn purple. These are where my marks happened, right? So you can see Twitter was ready, and then all of this time, and Twitter end, and there's my measure right there, this big red bar. So Twitter took a lot more time than I took inside of non-content loaded to make things happen. All right. Cool, Nick. You just showed us how to gather up a bunch of data in the console, but what do I do with all that data? It's stuck in the browser. Working group comes to the rescue one last time, and they've introduced something called Beacon. Now, theoretically, you could just take all the data that I showed you how to gather and store it into local storage, and at some point in the future, Ajax it back up, and that's fine. But if you've ever tried to actually build a beacon that sends reporting data silently back to the server, it's harder than you'd think. First of all, the best time to do that is in the unload event, because that's when everything has been downloaded for sure. But if you make an Ajax call, an asynchronous call inside of onload, all the major browsers will just completely ignore your call. They'll never even make the request. You can fix that by going synchronous, and then it will honor your request. But then you have to wait for all the data to get sent back up to the server and the response to come back. And so you put a performance penalty on your page to figure out if it's performant, which doesn't really help the situation. So they created this thing called Beacon. And so you can use it anywhere, but I'm showing you here inside of onload to get around that problem that I just mentioned. So I wire up inside of my onload handler event. I just grab all the data that we just looked at, the navigation timing, the resource timing, and the 2 different user timing calls to get the marks and measures. I take all of that data and I put it into an object called rum, and then I say navigator.sendBeacon. Where do I want to send it to? I'm going to send it to rum/submit, and I just want to take that data and serialize it as JSON. And boom, that will get sent up. It gets sent up really smartly. If the browser is really busy downloading a bunch of important content, it will put this on a lower priority, and when it needs to, it will send the data to you. It will get there. It's also, because it's so concerned about performance, it's the only time that the browser will not wait for the response. It sends all the data up there, and normally it's like, OK, I'm looking for a 200 or a 404 or something. It's like, here's all the data. I'm running away. I don't care. Right? And so if you blow up, you'll never even know about it from the client perspective. So don't blow up. I sent that data to RUM controller. This is what my RUM controller looks like. Apparently, I don't have JSON serializer installed anymore. It's OK. We're not going to run this code. So basically, you see that I am posting the data to this controller. I take my JSON serializer, and I read the data off of the input stream. I deserialize it into this RUM object. The RUM object kind of looks like what you would expect it to. Here's all of the resources from the resource timing spec, the navigation object from the navigation timing spec, marks, measures. And I want to point out that I also capture the refer, the user agent, and the IP address. All of those things basically come from host headers. I'm sorry, all those things basically come from HTTP headers. Because a beacon is just a standard HTTP request. So I can gather additional metadata like what page the user was on, that's refer, what browser and OS they were using, I can kind of glean that from user agent. And with IP address, I can figure out where in the world was this user. And now that I have all of that data, I can start filtering and parsing and chunking and looking at the data through different lenses. So that's nice and handy. OK, cool. So we just did a blitz through RUM, real user metrics. RUM is really good for answering the question, is my page fast? And getting the real answer. Not because it works on my machine, but because the guy on the camel in Egypt says that it's fast. RUM is not good at answering the question, how do I make my page faster? So it's all about observation, and now we want to start to orientate ourselves around all of this data. For that, we use synthetic testing tools. Synthetic testing tools use specially instrumented browsers, highly instrumented browsers, that can give you a lot more data than you're going to get out of RUM and allow you to figure out the inner workings of how a page is being loaded and operating and then make changes. My favorite tool, synthetic testing tool, is called Web Page Test. It's free and open source. There's a public service available online at webpagetest.org. And they have servers at all of these locations. I painstakingly made this map accurate for you so you could see all of the places where Web Page Test is running. There's also an airplane there. That's because for 3 hours, when Pat Meenan, the creator of Web Page Test, was flying to San Francisco, he loaded up a server. So you could see how your page loaded on that Virgin America flight. True story. True story. So I will also point out that the browser and OS support is extremely good in Web Page Test. The only thing that you might want to use that's missing is mobile IE. All right, so let's take a look at how to use Web Page Test in my browser. All right, so I'm going to come back to my home page here. I'll grab this URL, and I'm going to open up webpagetest.org. This is what it looks like. It's sparse. You basically paste any URL that you want to in there, and then that's the URL that you're going to test. Now, the one thing I do want to point out, though, is this number of tests to run option. You basically always want to leave this at 9. Because the way that Web Page Test works is it's actually making a real call across the real internet. So if I test this same page right now, and I test it again in an hour, I'm going to get different results. Why? Because the internet is a fickle place, right? Like, somebody could be microwaving popcorn and like my website is slow. That happens. And so the way to get around that margin of error is Web Page Test will make however many number of requests you ask it to make. So 9 is what I'm recommending since that's the max. And then it will find the median value, the value in the middle. So that's the most normalized, and we're getting rid of any outliers that are really slow or really fast. However, this can take a little while. So for today's purposes, I'm actually going to leave this set to 1, and I'm going to go ahead and start my test. Now, you'll see that this says that I'm waiting at the front of the queue. This is a public service. All of you could have just really quickly gone and started tests on Web Page Test, and then I would be waiting in line. I appreciate that you didn't, but at some point, my test will get picked up from the queue. The browser that I selected, which is Chrome in this case, will literally fire up, make a request to my page, download all the assets, and capture a whole bunch of data. And you see my test started 19 seconds ago. Now, this could be very tedious for me to wait all of this time every single time. So I mentioned I'm fat. I watch a lot of Food Network. And so I kind of Mario Batalia'd this. And so down here in the oven, I have some pre-cooked tests ready to go. So here's that pre-cooked test. The test that I loaded up here was this minor league baseball page. This is a very image-heavy page because it's all of the mascots for all of the leagues on one page. And so that's the page that I've loaded up here. I've loaded up the unoptimized version of that. And so web page test gives us a whole bunch of metrics and information that we might want to see, including the waterfall. So let me go ahead and look at this waterfall. Like I said, lots of images, so you'll notice that it's very, very, very long. Yeah. What are we at? 334 images. That's fine. You might have seen this in F12 tools before. But what I think is really cool is that, remember, this is highly instrumented browser. Here's the CPU utilization and the bandwidth utilization for when that page is loading. And so if you notice, right here between somewhere in here, like 2.5 to 3.5, the CPU is basically spiked, right? And so if I scroll all the way up to see what was kind of happening at that time, intersects with this section right here, I downloaded a bunch of JPEGs. And so my guess is that was when the CPU was decoding those images, because there's a cost to that. And so I can kind of see all of that stuff, which is awesome. You might also notice that I get a rules-based metric here. I get a bunch of grades. It looks like a Christmas card right now. I got a lot of Fs. This looks like my middle school report card. But remember, this is for the before page. If we switch to the after page, my grades get much better, right? Yeah, thank you, Nick. And so if you want all A's in your report card, go ahead and watch the video that I mentioned. So that's really cool. What I think is really slick about web page test is not just looking at all the data that it has to show you, but digging in and doing a comparison. So I could come into my test history, and let's see if I have any test history. There you go. There's the test that I ran for the last 30 days. I can just check any 2, 3, up to 9 boxes and hit the compare button. And when I do, it will open up a page that looks like this. So on the top, you'll see 2, which is the second version of the site, version 2, the optimized version, versus the unoptimized version in a film strip, just like the one that we looked at when we were talking about speed index. And I can scroll through and see what things looked at. So at 3 seconds, on the optimized version, we are completely rendered. And at 3 seconds in the unoptimized version, we are a white blank page, which is a great Mumford & Sons song, but it's a horrible user experience. No hipsters. All right, I'll scratch that one. That's fine. We don't have to. And so you can see 4 and 5 get loaded through. What's also really nice is I get the 2 waterfalls from version 2 to version 1, and I can move back and forth the slider and change the alpha transparency. And so you'll notice the unoptimized version, look how that big blue bar at the top, that's my server backend time. And my optimized version, look at that, my backend time got shorter, and not only that, but I flushed the HTTP response, so I started downloading stuff before I was even finished, which I wasn't doing before. And so we can kind of see a big change happening there. The other thing that I think is really slick is, you see this red line right here? As I scrub the page, that red line in the waterfall chart lines up with this red line on the side of the film strip. So this is what was happening on the networking stack at that moment, and then you can see I downloaded some stuff and stuff showed up, blah, 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 all the way through. So I can literally see the effect that downloading a file will have and how it will change the page. If I scroll down, way past my 334 images, I get a visual progress indicator. How many people recognize this chart? Yes, this is how speed index is figured out. So I can compare the 2 versions and see what they are. And if I don't want to do integral math, because I don't, I can just come down a little bit farther and I can see the speed index of the optimized version is 885. The unoptimized version is 3,976. That's almost a 400% increase. And we can see all the different milestone metrics and compare them. We can see the different number of HTTP requests, which kind of stayed the same. And same with the number of bytes downloaded. You can see that one got a little bit better than the other. So that's very cool. Let me do this. What's really cool, though, is this create video button. When you press that button, it literally creates this video for you that shows a side-by-side comparison of how the 2 different versions are loading against each other. And so does anybody have, like in their office, one of those walls with like 10 clocks that you don't care about? It's like New York, Tokyo, Okinawa, Piedmont, North Dakota. Like, does everybody have that? Like, okay, that's cool. I say, instead, why don't you run your website from those 10 different locations and have those videos side by side so you can see how your site is being compared, which is something that I've done before, and it works out really well. Now, one of the things that I really like about the guy behind Web Page Test, his name is Pat Meenan, and he's sponsored by Google to work on this, is he's he's in the community, right? He knows what's going on. And so as all of these RUM specifications are coming out, like user timing, he's adding that into web page test. So now look, I'm looking at Balapino's tweets, right? My favorite guy's tweets. And there's these little triangles that show up here. These are my user timings, the manual ones that we added in, Twitter ready, Twitter rendered. And so I get that data showing up right in line, right? The instrumentation that I added is now live in this site. So that's cool. Web page test is super powerful. I'm going to tell you about one more feature, right, which is the connection speed. You can manage it, and if you want to see what it looks like on a 3G connection, you can select that and then run your website through a 3G connection. But what I really like is this SPOF tab. SPOF stands for single point of failure, and many of you guys probably know what that is, right? You know, like if your database goes down, your whole website is screwed because that's a single point of failure. There's single points of failure on the front end as well. I included that script from Twitter. What would happen to my website if Twitter went down? I tried to call them and ask them to have like just a 30-minute outage so I could see and do some testing, and they weren't cool with that. OK, that's fine. I come into web page test. I put in that host name, which was platform.twitter.com. I have pre-cooked results, so it doesn't really matter what I type. I put in that URL, and now when I run this test, platform.twitter.com is down for all intents and purposes. And so what ends up happening is I get something that looks like this. Let me go ahead and do the comparison. So this is showing on the top what the same page looks like when Twitter is up, and on the bottom what happens when Twitter is down. So when Twitter is up, we go to 1.8 seconds, and we're completely done rendering. At 1.8 seconds when Twitter is down, we have the header in the background, but none of the other content on the page. So we keep on going. We get to 5 seconds, no change. 10 seconds, no change.
Good thing you never have to worry about Twitter going down.
Yeah, good thing. 15 seconds, no change. 20 seconds, no change. And at some point, 21 seconds later, the browser says, you know what? Forget about it. I'm not going to load Twitter, and I'll just go on with the rest of the page. And so you can do really cool SPOF testing with that stuff. All right, how many people think that web page test is pretty cool? Yeah, it's awesome. It is awesome. But don't get too caught up in just web page test, right? That's synthetic testing. That is orienting yourself around the data and figuring out how you can make a decision to make things faster. The companies that are big into performance, like Etsy and Google, and actually publish their performance data, they all have charts that look like this. Their synthetic testing, they use web page tests themselves, all show that their websites are 2 to 3 times faster than the actual data that they get from real users. That's because people make popcorn, guys. That's because there's weird things that happen in real life that aren't accounted for. So the truth of the matter is, well, RUM is great at telling you, is your page fast? And synthetic testing is great at telling you how to make your page faster. You need to use both to have a complete story. All right. I got 13 minutes. Let's keep it moving. So the question you might ask me then is, well, that's great, Nick, that you can run this test and you can do these things in the console. But how do I just bake this into my process? I want this to always happen. I want fast to be a feature. And so luckily for us, the JavaScript community and the rise of tooling around NPM and Node like Gulp and Grunt have risen to the occasion. And they provide lots and lots of valuable tools that you can use. So I'm kind of an equal opportunity guy, so I'm going to show you a couple of Gulp things. I'm going to show you a couple of Grunt things. For the most part, if you're a Gulp fan or a Grunt fan, it doesn't really matter. You can do most of all of this in either of them. So I'm going to run a command called Gulp PSI, which stands for Pagespeed Insights. What's happening right now while that runs is their request was made to Google's Pagespeed Insights service. Google requested my page, the homepage of the optimized website. It put together its rule-based metric and came back and told me that I'm a good boy. My score is 97. And it gives me a bunch of information about that page. Now, let me show you how that's set up. If I go here and I look at my Gulp file, you'll see that I have PSI set up here. Here's the URL that I'm using a desktop-based site. This is a mobile site. And my threshold is 90. Now, that threshold means that if my score ever dropped below 90, if I went to 88, the command line would throw an error, which means that if I was running this in TeamCity or Travis CI or whatever my continuous integration service is, I would break the build. So checking an image that's way too fat, put some unoptimized JavaScript in there, build broken, because I'm not following the best practices. Let me show you a sister task called gulp TMI. That's what happens when you ask Cecil what he did last night. Now, in this case, it stands for too many images. I'm going to go ahead and run that. It uses a very similar service in the back end to look up some data, but this is showing me information about my images on my website. And so I am 139K worse than the websites on the internet that they scan, which is hundreds of thousands of them, that at the 25th percentile, but I'm a little better than the 50th percentile. I'm 331K better than the 50th percentile. That's a good way for me to kind of judge where I sit in the ecosystem of things. So let's go ahead and take a look at some of the grunt ones. So I'm going to say grunt perf budget. This one takes a little while to run because what's actually happening now is grunt perf budget is making a call to webpagetest.org. That website that we were just using the whole time has an API. So they are running a web page test, which you know can take like 30 to 40 seconds, which is why I'm dancing right now, hoping that this thing finishes. And it gathers up all of the different metrics and all of the data that we just looked at from web page test. And then I have some assertions. I have thresholds, once again, that I apply to that. And it will see if my website meets those thresholds. And so while this is running, I will show you the setup for that file. Oh, perfect. Oh, I passed everything. I'm awesome. So my speed index was 696 for that request. My budget is 1,000. My bytes in, the total bytes downloaded, I think is a meg. And I'm under that, and I rendered quickly enough. And so you can see it's very similar to the PSI thing. I can just come in here and say, here's my website, and here's the budget that I want. For any different metric that I want, I can set it up that web page test captures, which is all of them. I will point out that you need an API key to do this. I've already downloaded one and I store it in my environment variables so you guys can't steal it. But if you just go to webpagetest.org/getkey.php, you can just fill out a form and they'll give you a key. That's good for like 200 requests a day. All right, so this is all great. Let's go ahead and run one more. I'm going to say grunt Phantomos. Phantomos is a kind of an ode to the technology that's underlying this, which is Phantom.js. Phantom.js is a headless browser. So when I just ran that command, a browser fired up that we can't see because it's headless, made a request on my page. All of the metrics about that request were gathered. And it doesn't really show me anything that looks too great on the screen. Instead, what it does is it takes all of that data and it dumps it out to an HTML file that looks like this. And so for every different metric, I can see, like I haven't changed my website in a while, right? So it's all the same number of requests and whatnot. Let's go down to something a little bit more interesting, like a milestone timing or something like that. Latency, here you go, my backend time. I've said I don't want the request to ever take more than 25% of the backend, and you can see that for the last 5 runs, I've been over 25, and so that's why that box is highlighted in red. I can click on this table, and I can see the actual values at each one of those points, and this entire dashboard is completely customizable. You can rearrange widgets, you can add widgets, you can remove widgets, and if any single one of them fails, you get that big red warning that's at the top corner of the page. So this is like the perfect thing to stick up on the monitor in the side of the team room so everybody can watch all the different metrics that you care about. To do that, you'll want to set up a process which is called a perf budget, which is you're going to say, this is what we as a team are shooting for. This number of images or this number of bytes or whatever it is. And you know, I'm not made of money. My wife and I have a budget, and if we go over budget, we have some options, right? We can either not eat that nice steak that we were just going to eat and then stay under budget, right? So don't build the new feature if it's going to put you over budget. We can find another way to get savings, right? Maybe cancel cable so I can eat steak tonight. And so in that case, maybe you'll find another feature on the same page that you can optimize so you can add in a new feature that would put you over budget. Or we could just not do it, right? There's actually a fourth option, which is go into debt, which is a really bad idea. Because going into debt with performance literally means you're probably going to go into debt. You're going to get less users showing up, you're going to get less conversions, you're going to get less eyeballs because Google pushes up faster sites to the top of the index. So I know I really quickly showed you those tools. There's a lot of grunt and gulp tools out there. If you come over here to perf-tooling.today and click on tools, this is a listing of all of the different tools, and there's icons for if it runs on gulp or grunt or something else that you can use that are all just performance oriented. All of the links that I'm showing you today, guys, are in the resources section at the end of the deck. All right, awesome. Nick, you just hit all these perf budgets, right? You picked 90 and you picked 1,000 for the speed index. Why did you pick those numbers? What numbers should I be using? Well, here's the answer. In 1968, a researcher who was working at IBM put together a study on latency times that were allowable by humans when they're doing a human-computer interaction. I actually think that's the name of the white paper. It's kind of a mouthful. Those studies were redone in 1993 and 2005 by Jacob Nielsen, and the numbers stayed the exact same over 40 years. So everybody in the UX world kind of considers these to be gospel at this point. Those numbers are that you have 100 milliseconds to make a user feel like something happened instantly. So what does that mean? That does not mean that you need to respond within 100 milliseconds. But if I'm on your website and I go to some button and I click that button, it needs to depress. It needs to look like I pressed it within 100 milliseconds. If you don't do that, I'm probably going to click again or think the battery in my mouse is dying. All right? Once I've done that, you have 1,000 milliseconds, 1 second to get a response to the page. All right? So acknowledge the gesture within 100 milliseconds. Do the work within a second. At about 3 seconds, people in the study started falling off to whether or not they were going to pay attention or complete their task. And at 10 seconds, everybody was done. So what does that mean for me, modern day Nick? If I'm on your website and it goes to 10 seconds and I'm waiting, I'm opening up a new tab and moving on to something else, and maybe I'll come back. Now, I point these out, but these aren't goals. It's not your goal to be under 10 seconds. That's the threshold. That's the do not cross this line. So what is a good goal? Well, Google, who, like I said, pushes up pages based on their speed, recommends that your speed index is 1,000 milliseconds. Now, you saw that my optimized version of the site was getting 700, 800 milliseconds. So that's good. It's easy to do if you know what you're doing, right? You spend an hour or two and you make sure you have good practices. That's not that difficult to do. Maybe you're in an intranet or you're doing some crazy business stuff that just, there's no way you can do that. That's fine. Do some competitive analysis. Look at what your competitors are doing, find their numbers, and be 20% faster than them. 20% is the threshold at which a user will switch from service A to service B on performance alone. If you're 5% faster, nobody cares. They don't really perceive that. I will show you one last tool in the 3 minutes we have remaining. I hope you took down my Twitter handle because we might not have a lot of time for questions. To do some of this competitive analysis, there's a website called the HTTP Archive. The HTTP Archive crawls the Alexa top 100,000, I believe it is, every 2 weeks and runs all of these metrics. It runs web page tests. It runs page speed. It runs all of these different tools on those pages as it crawls them, and it stores it into a giant database. So you can come to this website and you can see the trends that tell you basically, look, everything is going up and to the right? The internet is getting fatter and fatter and slower, no matter how many times they come and speak at Code on the Beach. But you can take this data and you can download it and use MySQL to analyze it, or you can come over here to Google BigQuery by following, there's a link here to write your own custom queries. And Google BigQuery is kind of like SQL Server Studio in the cloud. Not really, but close enough. And so you'll see there's tables for all the different runs. The first run that happened in October of 2010, and then every 2 weeks for the last 5 years. At the bottom, there's a table called latest pages. That's whatever the newest data is in that. And so if I like using that table because I never have to change names. And you'll see that the columns that are in here are columns that we recognize. Time to first byte, render start, on load, page speed, speed index, all of our metrics. So we can figure out how the internet as a whole is doing, or at least the top sites. I'm going to cheat a little bit here and do some copying and pasting because we're low on time. So I'm going to take this query. Let me go ahead and query the table. If you're used to SQL, this looks very similar to SQL. Let me go ahead and run it and I'll explain what this is doing. So I'm taking some of the metrics we've talked about today. Speed index, time to first byte, on load, total number of requests, total number of bytes downloaded, number of domains, and the page speed score. And I'm breaking it into quantiles. You see that inner quantiles call. And then the outer call is I'm selecting the nth. I'm selecting the 50th of the 100 quantiles. So I'm getting the median. I'm getting that middle value. And so you can see for the top websites on the internet, the median value is a speed index of almost 5 seconds. The recommendation is 1,000. They're almost at 5,000. The total number of requests for the median big site on the internet is 75, which I think is ridiculous and crazy. And you can see the rest of them. Let's go ahead and dig into speed index a little bit more since I'm telling you that's the one to focus on here. This query is basically the same query, but I'm only looking at speed index. And instead of getting just the 50th percentile, the median, I'm getting the 10th, 25th, 50th, 75th, and 90th. So there you go. The median, again, you see that 4875, the same number we saw in the last query. But here you go, the 10th percentile, almost 2,000. So if you can get the Google recommended 1,000, you are better than 90% of the internet. Hell, even more than 90, like 95% of the internet. And I know that sounds scary because you're like, holy crap, these guys can't do it. What makes me think I'm going to be able to do it? You can do it. They just don't care. You should care. OK, there's a bunch of other queries that you can do. I won't get into my other examples. If you're interested in this and want to know more about how to query this stuff, go to Bigquery. It's a .es domain. They got a little kind of too cute for my taste. But this is where the guys who created that website, Ilya Grigorik and Steve Souders, this is where they go and they post their queries that they're using. And lots of people show up here and say, how would I query the data set to figure out this? And they will walk you through and help you with that. They're very friendly fellows over there. So we are at 2 o'clock on the dot. I will tell you that I have a longer version of this session available on Pluralsight right now. And I have 2 free month-long subscriptions to Pluralsight for the first 2 people to come and grab them. I also have 1 stickers. And within the next 2 months, I will have a 3-hour-long course just about web page tests and all of the details on it. If you want to get all the resources that I mentioned, you can go to my blog, nikcodes.com/tracking-web-perf, or take a picture of this QR code. It will take you there. My Twitter handle, my email, all my contact information is there. I appreciate you guys coming out. You were great. I was awesome. Thank you.